Hello, Mr. Harry, Mr. Ryan, are you right?
Yeah.
Okay, so look, we are given a list of words. Ryan, Eric, and we also give a string. ERIC, So the question is that can we break this string using the words given here? And each word can be used multiple times. So look here. Look for this one. Eric is here, right? So we can use Eric this here, and we can use the Ryan here, and we use the N here. Okay? Make sense? Okay, so another example. How about S equals ERIC, AND, RYAN. Can we?
Yeah.
Yes, because as I said.
What if there's RYANERIC and no and?
Good question. Yeah, that's okay. Yeah, that's a very good question. So each word you can use it, or you don't need to use it. And each
What
word.
if it is EDHIRYAN RAY?
No, right? Because you can't find. We have to complete the string, the sentence, the string using the words, and each word can be used multiple times. Okay. How about another one? Okay.
Egg is delicious.
Cats and dog. Can we? No? Right?
Because there's no S.
That's right. Yes. And how about if I put the S here?
No, because there's no S.
Yeah. If I put the S, why not? Look. So, cat, sand, dog. Okay? Yeah. You get the point, right? How do we solve this problem? If we ask the mommy to solve this problem, what do you think she will try to do?
Look, Rufus.
Say I don't know.
How could she probably say? But given this very simple example, she could, as a normal people, what would you try to do? I mean, for example, this Eric. How? My question is that given this, right? Given this list of words and given this S, how would you do it? I mean, how would you do it? Without any programming knowledge, right?
You just Rufus.
Yeah. How? I mean.
Just take him.
Every possibility.
Yeah, but you need to be more specific, not just saying algorithm, right? So yes, it's brute force, yeah, or depth search or breadth search is also okay, or dynamic programming. These are all okay to solve this problem. But what I'm asking is, how would you solve this problem by guiding me through, right? So given this sentence, how would you find out if this sentence can be broken into these words given?
I'd put the word in the dictionary and then check if it's in the string.
Yeah, you mentioned very good point. Dictionary set. Yeah, because we're given you the list, you'll be more efficient if we use a set to store this list of words, right? Because there will be one constant time to look up if a word appears in the list. List of Okay. You said that to look up the words in the S. Right? By going through this
String.
Then how? So look, I will check if E in the string, no. If ER in the string, no. If ERI in the string, in a given list, no. ERIC, yes. Okay, then because ERIC is in the list, so what would I do? I will jump to the next word, and then repeat until I reach the end. Am I right? I'm here, right? Okay, I check if E.
Yeah.
Is in a list if it's a given. No. ER if it's given. No. ERI if it's given. ERIC if it's given. It's given. That's great. Let's check if in the next word, right? And I can repeat this process as many times as I want, right? Using so you basically using this depth search. I would be the index. Yeah? Or the index we are currently at. So at the beginning, I'm standing here, I equals 0. Right? I can jump forward if I find a word in here. For example, Eric, and I can jump here. Eric, I jump here. N, I jump here, right? Ryan, if I'm reaching the end, then I find a solution. Alright? So if not, for example, if this one, cats and dog, okay, so cats and dog. Cat, in a word, I jump here. S, SA not in the word, SAN not in the word, SAND not in the word, not in the word, and then I clicked because there is no way to jump to the end.
Yeah.
Yeah, that's one way. The other way is slightly different. So every time I'm still jumping, but every time I go through this word, so for example, I'm here. So instead of checking ER, ERI, ERIC, checking the next possible word, yeah, I will just go for the opposite. I will go through these words and then check from the current positions to this length, if it's Ryan, if it's Eric, if it's N. Yeah, slightly different. Okay. So if I equal the length of the string, then we return, as I said, return true, right? Right? Because look, if we are reaching the end, we are be able to jump to the end, then we find the solution, alright? If not, then we go through it for the n, yeah? For n in range from I plus 1 to the end of the string plus 1. This is to do the one position beyond the end, okay? So we have to plus 1 here, right? And then what do we do? If Si current position up to n, if it's in the word, yeah, in the word, we can convert this list of words to W equals set of words. Yeah, we convert it to words. What's the advantage if we do this? We convert the list to the set. What's the advantage?
The advantage is the lookup.
Lookup time, yeah, because of 1. Because if you are looking a word in this, there will be linear, you know. Yeah, you have to check each word one by one, and then the time complexity will be O n times n. If n is the number of the words in the list, m is the average length for each word, you have to do this. But if we convert it to a set, it's O1 constant time because it has table, okay? Now look, if it's in the word, and also depth first search, if it's in the word and then we start with the n, we jump to the n, right? Then return true. Otherwise, return false. One thing is missing here.
Cache.
Well done, cache. If we not put in a cache, what happens? Because look, we are jumping. Yeah? Each position, each index, we can split or not split. So they are for a length for a string given the size of n, we have n plus 1 ways to split. So the time complexity will be exponential O to n. But for this one, if we put a cache, I is the index. There could be at most n states, yeah, n states from 0 to n minus 1, right? So there will be n states. For each one, we iterating. So look, each one we iterating on. And then look, this substring is on. So the time complexity will be on times on times on, right? Look recursively here. So the time complexity will be on cubic, right? On cubic. So what we just need to call is return outside, return DFS 0, okay? Yeah. By putting a cache, yeah, without a cache, let's brute force depth first search, okay? O to n. By putting a cache, this is basically like top-down dynamic programming, yeah, because we're remembering the intermediate results. So we don't repeat for each DFSI, we only calculate once, right? Okay. So that's one way. Okay. What I mentioned about the other way, slightly different, is we are not iterating over the next split point, right? We are not. This is to iterating the split point, but we are not iterating the split point. So here, yeah, this is the same, and then from this line, we are doing this for A in W. Yeah, we're going through the dictionary. Yeah, now we just check. Going through the list of the words, we just check E. The next, for example, this is for the length of 4. The next 4 characters, if it's the same as this, if it is, then we can jump, right? So the length will be what? NA equals length A, and then the string. So if SI up to NA, right? So I plus NA. If it's equal than A, right? If it's equal than A, and also depth first search Yeah, depth of search, we jump to the end. Jump to the next one will be I plus NA. Then return true, otherwise return false. Slightly different. Yeah, here, this one is to jump to the next split point. What are we doing here is to go through the list of words one by one and then check if we can jump to it. Right? And basically, we are also calling it itself the depth of search.
Yeah, right.
So what have you learned today? Come on, what have you learned today?
About
Word break.
Word break. Yes. What's the problem? Okay. So can we practice?
probably there's some words and a string, and you want to find if the words in the string are in the words.
Okay. So we are given a list of words. Yeah? List of words. These words are unique. We can use the words as many times as we want, including 0 times. And the question is that given another string, we want to find out if we can break the string into words given by the list. Today, our approach, brute force, depth of search, yeah. And if we put in the cache, there will be top-down dynamic programming or recursion with the memorization. The depth of search I means that what? I is the index, right? So it means that if we can split the sentence from the index I. At the beginning, from index 0. Index 0 is the first character. If we be able to split the sentence, split the string from the 0 index, right? From I index I. So if it reaches the end, then we find a solution. Otherwise, the next index, the next split point, this is the split point, will be from I plus 1 to the n. And then this is the substring. If I, from the I to the n, in the words, and also, if this is in the words, then we can check. We can jump to the next one, which is the end, right? Then we return true, otherwise return false. For this 1, 2, 3, 4, we can use the any keyword, yeah? Because look, this is basically to check if any, yeah? If we find a solution, if we find any solution here, right? We can return any si to the n in W and depth of search n for n in range I plus 1, right? Let's using the fancy syntax ending. Okay, that'll be it for today. Bye bye.
Ah!
Bye bye.